Hello everyone, welcome back to the live out lectures on engineering mathematics. We are here with the Ekeeda, and today, like we have already been discussing calculus, so today we'll be discussing the topic of multiple integral, where we'll be having like 4 or 5 types of questions, and other than that we'll be moving into gradient, divergence and curl. So meanwhile everybody is joining, of course, as usual, you can share the link with your friends and we can have more number of students here and we can have more energy, right? So this Sunday we can like learn something good and great. Okay, hi Kirti, good morning Kirti. So okay, I see people joining here, right? So today the first topic we are going to discuss is multiple integral, and in this topic first of all we'll try to find a evaluation of a simple double integration, right? After that we will also see good morning Amarjeet, good morning Avinash. After that we'll try to move into the topic of understanding the region of integration, the region of double integration. Then we'll also see how to change the order of integration, like if it is dx dy you can change it to dy dx, right? Other than that we will also see the application. The application can be like finding the volume. It can also be finding the double integration of complex functions, which will be like it will be required to change the order of integration there, right? And after that we'll move to the topic gradient, divergence and curl, right? So we have gone through the I'll say the theory part of all these topics, and we'll be moving into the questions now, right? Good morning Lokesh. So we'll be moving into the theory, from theory to questions, and we'll try to solve the gate questions, previous year questions, right? Okay then, so I think we should start now, like moving into the question now. Good morning Mohammed, good morning Sameer. Okay everybody, so let's start with the first question. Before solving this question, let's see what we have to do here, right? For the case of double integration, we have to, like, so far we have done the integration in terms of one variable, right? Like dx, general dx. So in this part what we are going to do is we are going to integrate in terms of two variables, and what we have to do is the method is to integrate in terms of first variable. Like if you check the order of integration here, the order of integration in this case I'll say is dy dx, right? So we'll start with integration in terms of dy. We'll consider, or I won't say consider it as a constant, I'll say you can fix it. You can fix the x. Of course that also means that you are keeping it as a constant. So keeping x constant, will integrate in terms of y. We'll put the limits of y, like in this case the limits of y are 0 and x, and then whatever result the expressions we are getting, we'll integrate in terms of the second variable, which is dx, and then putting the limits of x, we'll get the result, right? So in this case, if you want, you can write this ex plus y as ex into ey, just for the sake. I mean, it's not required, you can keep it like this. And the limits of y, if you see, the limits of y is from 0 to x, right? And the order of integration here is dy dx. So we'll start integrating in terms of dy first, and then we'll move to the dx. So let's start with the first one. So it is going to be ex ey integration in terms of dy and this. I'm just keeping the outer integration out, like just we are leaving it for now. So if you see in terms of dy, ex is going to be a constant, so we can keep it, treat it as a constant and integrate ey. So integration of ey will remain ey and the limits are 0 to x. So this is going to be e to the power of x into e to the power of y, where the limits of y is 0 to x. So this makes it, when you put x, y is equal to x, this is also y is equal to x, this is y equal to 0. So it is going to be e to the power of x into e to the power of x minus e to the power of x into e to the power of 0. Correct? So e to the power of 0 is 1. So you can write it to be e to the power of 2x minus e to the power of x. This is the integration of the internal part. So what we are left with is now from 0 to 2. What is this 0 to 2? This is x equal to 0 to 2. These are the limits of x, the lower limit being 0 and upper limit being 2. What is the integrand now? This is the integrand. So integrand is going to be e to the power of 2x minus e to the power of x, integration in terms of x. So let's integrate this one, and now you can easily do it, right? So e to the power of 2x will be e to the power of 2x by 2 minus e to the power of x simple. The limits are 0 to 2. So just put the values, that's it. It is going to be for x equal to 2, e2 into 2, so e4 by 2 minus e square minus, when you put 0, e to the power of 2x will become 1 by 2 minus 1. So overall this becomes minus half. I'm writing it here. So if you are taking the LCM, you can write it like this: e to the power of 4 minus 2 e square and minus and minus plus, so plus 1. And if you want, you can write this expression, or you can, I'll say, manipulate it, or you can resolve it, and the function will become e square minus 1 whole square by 2. So this is what they want, right? If you see the options, option number B is the one which is like very similar, or similar what? It is exactly the same, right? So even after finding the limits, you had to manipulate it as per the options, right? So that is required some of the time. So this is how you have to do or evaluate the double integration, considering one at a time and then the second one. Fine. So I think this is good. B option. So let's move to the next question now. All good? Sameer? Chalo. Next question. The next one. This is a 2 marks question from EC department 2017. We have to find integration of two of the functions given here. So again, when you are integrating in terms of the first variable, the inside one, so this is dy. When you are integrating in terms of dy, you'll have to take x as a constant, right? Or you can say you are fixing it. Hello, Shilu Yadav G. Good morning. So let's see. So now what you are doing is you are treating x as a constant, or I'll say fixed. Anything is fine, right? And you have to integrate in terms of y. So when you are integrating in terms of y, if you see, this is this integrand in terms of y can be integrated in using the concept of, or using the method of partial fraction, right? So what I'm doing is I'm writing the numerator as x plus x minus y divided by x plus y whole cube. Fine. You're treating x as a constant here. So what you can do is you can split it as 2x by x plus y cube. We are just moving into indefinite integration, then we'll put the limits. Very easy, right? So this part can be written as minus of x plus y. So minus of x plus y in the numerator and denominator gets cancelled, and this term remains as x plus y whole square. So this is the integrand inside, and you have to integrate it in terms of y from the limit 0 to 1. Fine, x is a constant as of like in this part of integration. So the first integration, x plus y cube, or I'll say minus 3 power. So this becomes 2x by minus 2 and x plus y to the power of 2. It's like a plus x plus c to the power of minus 3. So minus 3 plus 1, and the denominator will be minus 2. BSc third. We are into gate engineering mathematics part, right? Shilu. Fine. And the next part is minus of, so this minus of x plus y to the power of minus 2 will become minus and minus plus by x plus y. That's it. Right? And you have to put the limits as 0 to 1. Fine. Put the limits. So the limits for 1, this is minus 2 and 2 gets cancelled, minus x by x plus 1 square, and putting 1 here, this is plus x plus 1. The lower limit when you are putting y equal to 0, these are the limits of y, right? So y equal to 0, this becomes minus of x by x square, which will be minus 1 by x, and this is also 1 by x. So these two terms get cancelled, right? These two terms get cancelled because it is minus 1 by x and it is 1 by x. So cancelled. So you are left with only this term. Now you are integrating it for the outer integration. So this is again 0 to 1, and the term integrand is minus x by 1 plus x square plus 1 by x plus 1, or 1 plus x, anything, in terms of dx. Right? So now you actually have a constant here. In the previous part you were taking x as a constant, but in this case you already have a constant here. So in this case, again, what you can do is you can use the method of partial fraction. You can write the first term as 1 minus 1 minus x divided by 1 plus x square plus 1 by x plus 1. Right? And just clarifying the terms, then we can integrate it. So this becomes 1 by 1 plus x square minus, now from these two terms we can take minus common, and it is 1 plus x. So from numerator and denominator 1 plus x gets cancelled, and you will be left with 1 plus x simply, and you have another term as 1 plus x, right? So you have two terms as 1 plus x. So you can cancel these two terms, and you have to integrate only this term in terms of dx, of course, from 0 to 1. So this is going to be x to the power of minus 2, like that, if you are substituting 1 plus x as another term. So this is going to be minus, the integration is going to be minus 1 by 1 plus x, it is 1 plus x, for the limits of 0 to 1. Put it like I'm reversing the limits for this minus sign. So it is going to be 1 and minus of half, so it is going to be half. So the first integration came out to be half, right? The first expression given is coming out to be half. Now I'm not going to calculate the second one. First of all, this value is coming out to be half. Let's see the next one. The second part is x minus y by all this term. So do you see the limits of x and y are same here, 0 to 1 and 0 to 1? What if I am taking minus common from this function? This becomes minus of y minus x, x plus, instead of, let's say, instead of x plus, I am writing it y plus whole cube, and integration dx dy, the limits are 0 to 1, the limits are 0 to 1. Now you compare this one and this function. Do you see any difference here? Just try to replace x with y and y with x. If you see, you are getting the same expression. The only difference is this minus sign. That means this is going to be minus half. That's it. You don't have to calculate it like entirely. So that makes it the first expression to be 0.5 and the second expression to be minus 0.5, and the answer will be option C. C option. Right? C is the answer. Clear? So although for one function you like it took some time, but for the second function you can directly answer it looking into the symmetricity of the function and the limits also. You have to check the limits, of course, right? It cannot be like different limits. You cannot do that. So C is the answer. So this is double integration again. Let's move to the, so basically what we are doing here, we were trying to integrate this like indefinite integration using the partial fraction method. Yes, fine. Let's move to the next question. So this is a different one. The first two were like similar one, I'll say. In this case, what you have to do is you have to change the order of integration, and that is what they'll ask you sometimes, right? This is what they are going to ask you sometimes. So in this part, you have to change the order of integration. How can we do this? How can we do this? For this part, the first thing required is to find the region for which you are trying to double integrate the function, right? And once the region is defined, you take any order of integration, you have to be in that region and you'll get the same value, right? So let's see. If you see the limits of y, like the order of integration is dy dx in the question given, and the limits of y is from 0 to x square, and the limits for x is given from 0 to 1, right? So it is y equal to 0. What is y equal to 0? This line is y equal to 0. The second line is y equal to x square. So maybe this is y equal to x square, right? Although this must extend this side also, but it is of no use for us as of now. So this is y equal to x square, and then the limits of x, let's use the same pen, x equal to 0. So this is x equal to 0, and the next limit is x equal to 1. So let's say this is x equal to 1. So overall you have to see what is the region enclosed here. If you see, the region enclosed is this one, right? This is the region enclosed, and for this region you are actually making the double integration. Now also when you are integrating into in the order of dy dx, the elements you are taking is the vertical element, whereas in this question, as we have to change the order of integration, the I is going to be something in the terms of the like the new limits. The function is, I'll write the function also, x y square, and the order of integration now is dx dy. Earlier it was dy dx, now it is dx dy. So we have to put the limits of x and y both. Now in this case, for the change of order, you should take the elements, like if it is dx dy, you should take the elements as horizontal element. And this horizontal element, if you see, the starting point is on the locus of the initial point. If you see, it is on the point, what is wrong? It is here. This is the initial point of this element, and this is the end point of this element. So the starting point lies on this curve, y is equal to x square. Instead of that, you can also write x is equal to, I'll say x is equal to under root of y. So that means the initial point lies on x equal to under root of y. The end point lies on this line, right? What is this line? This is x equal to y, 1. So x equal to 1. And this element, this horizontal element is defined in what region? So this element is defined in the region of y equal to 0. Like this element will start from here, this element, these all are horizontal element, and this will keep on going up till this point. What is this point? This point is y equal to 1. Why? Because x is equal to 1 and y, this line intersects. So y is equal to x square will give you the value of y, right? This y equal to x square, intersection of y is equal to x square and intersection of x is equal to 1 gives you this point. So that means these horizontal elements are defined from the region of y is equal to 0 to y is equal to 1. So that means the limits for y will be from 0 to y is equal to 1, right? So now you can check the option whichever is right. x y square y0 1 and under root y 1. So this is the answer, option C, right? Option C is the answer. Done, everybody? Is it all right? Yes, Lokesh. So let's move to the next question. Do this one. I mean, this is a similar one. You can do it by yourself. Mechanical 2009. Let's see the region again. So in this case, there is a function, let's say f(xy), and you have to check the order of integration is dx dy, right? In all the four options you can see this, and there is a constraint for this function. First of all, it has to lie between 0 to 1, and second, it has to fulfill this condition. Now, what is x greater than y square and what is y greater than x square? Before x greater than or y greater than x square y square, let's see what is x is equal to y square and y is equal to x square. This function let's say this function is y is equal to x square, and similarly these two parabola, right? The equations are for parabola, so this is x is equal to y square, right? So we have got two functions here. Now they are not talking about these lines, they are talking about something greater than that. Now my question is, what is something x greater than something? Like if I say x is greater than 5, what do? You draw a line x is equal to 5 on the xy plane, and then you take all the points on the right side, because x positive means on the right side, x less than something means on the left side. Similarly, when you talk about y greater than something means upward, y less than something means downward, right? So if it is x greater than y square, this line is about x equal to y square, but we are concerned about the x greater than y square. So x greater than y square will be this part. The right half of the curve x is equal to y square is something x greater than y square. This region is x greater than y square. Similarly, when it is y greater than x square, you will have to move upward. So this region above y is equal to x square is y greater than x square. And in this entire region bounded, what you are getting, what the enclosed area is this one. This is the enclosed region. Because this is where both the conditions are satisfied. Why we cannot go beyond this line? Why we cannot go beyond this line? This line? Because this condition will be fulfilled, but x is not greater than y square in this case, right? X greater than y square lies here. So we cannot go beyond this, we cannot go beyond this also, because once you are going beyond this, this is a region where y is less than x square. Similarly, this is a region where x is less than y square. So this is the region boundary. And what are the points of intersection here? The point of intersection, this is obviously 0, 0, option A. I think, let's see. And this point is like where both the conditions, both the curves are intersecting. So this is simply 1, 1. Satisfy both the equations, you will get it. So I'm drawing this region again. This one is x is equal to y square, and this one is y is equal to x square. This is y is equal to 1. This is x is equal to 1. This is y equal to 0, and this is x equal to 0. So the region bounded is very clear now. This is the region bounded. Now dx dy. So if it is dx dy, we will take the element as horizontal element. So this is the horizontal element we are taking, and this is the initial point, and this is the end point. So the integration from x equal to and from the limits y for the function, what is the function? F of xy dx dy. So this is the initial point. This initial point is nothing but x is equal to y square. So x is equal to y square is the starting point, or you can say the locus of the initial point is x is equal to y square, and the end point lies on this point, this curve. This is the curve y is equal to x square. So if y is equal to x square, x is equal to root y, right? And what are the limits of y for which these horizontal elements are defined? So you can start from here and then you can cover up all this region up till here. So this is nothing but starting at here, y is equal to 0 and ending at y is equal to 1. Yes. So the limits of y is 0 to y equal to 1. Now you can check the option. Yes, option A is the right answer. Option A is the right one. Right. So you need to understand the region and the limits ultimately. That's it. Fine. No problem. So let's move to the next question. So these are the questions related to the change of order. That is what they ask you like very often. Or maybe sometimes it is of some application also. Let's see the next question. Let's see this one. Let's see. So the order of integration in this case is dx dy. Right? I'll give you two approach, and you will have to decide which one is like better one and which one you should drop. Right? And I won't solve it. Right? Because it is all about saving your time in the examination. So let's see. In this case, what if we are taking two methods? Like the order of integration in the first case or in the equation is already given as dx dy. So if you are taking dx dy, you will have to take the limits of x, right? First of all, you will have to take the limits of x, and then you will be taking the limits of y. The function is c times. Let's take this constant c outside, and this is x y square dx dy. So since the order of integration is dx dy, you will have to take horizontal element. But do you see that these horizontal elements and the one which I have drawn like below is different? What is the difference? The difference is the locus of the end point and initial point. Although the end points are same, the initial points are different. In first case, let's say this is h1, horizontal element h1, and this is horizontal element h2. So if you see in the h1, the limits are from like this. What is this? X is equal to 1. And ends at x is equal to 5, whereas afterwards it is on this line. What is this line? If you see, for x is equal to 1, y is 2, for x is equal to 5, y is 10. So you can clearly see this is nothing but y is equal to 2x, straight line which is y is equal to 2x. Now after this limit, what is this limit? Y is equal to 2. After this, what happens? The initial point of this curve changes to x is equal to y by 2, right? So this is the issue here. What is it? We will have to take two limits. The first one is, I won't solve it, okay? The first one is taking x is equal to 1 to x is equal to 5, but the limits for y will be from 0 to 2 and whatever function you have, like c times of xy square dx dy. And secondly, after this region, after which region? After this region, y is equal to 2 for these elements, right? The first one is for these elements, the second one is for these elements. So now the limits will change and it will be from y is equal to 2 to 10 and x will be y by 2, as the line is y is equal to 2x, and it ends at y is equal to x is equal to 5, and the same whatever function it is, and dx dy, right? But I'll suggest this is something which will take more time, and of course I'm not solving this one also. What we are going to do is, instead of this method, I am taking a vertical. Is it visible? Okay, I'll rub this. Maybe I'll rub this and you'll be clear. I'll solve it in the same part, right? So now what I'm doing is I'm taking okay, good. What I am doing is I am reversing the order of integration. I'll do this one, x y square dy dx. Why we can do this? Because we know the region here. The region is specifically given. The limits are not given. So my consideration is to change the order of limits. So if you see the limits of y, it will always lie on this line. What is this line? This line is y equal to 0. So let's take y is equal to 0 here. And the end point lies on this line. This one. Right? What is this line? This is y is equal to 2x. So the limits are y is equal to 2x. And secondly, the region for which these elements are defined as x is equal to 1 to x is equal to 5. So that means x is equal to 1 to 5 is what we have to do. Of course, there is a constant c also. Right? So do you see, instead of taking in the order of dx dy, taking the order of dy dx is actually helpful. You'll have to do very small calculations. You won't have to do 2 of the integrations, and you'll get the answer. Right? So let's do this. Xy square. Let's keep the constant outside c and find the limits. Of course, you can do this. So I'm doing this. So integrating with respect to y first, it will be x times of y cube by 3 with the limits 0 to 2x. And then integrating in terms of x from 1 to 5 dx. Right? So this is going to be, if you put 2x, this is going to be 8x to the power of 4 by 3 for 2x, and for 0 it will be 0, simple. And you have to integrate in terms of, the limits are 1, x is equal to 1 to 5. C is outside always, right? I am not writing it, even then you should consider that C, dx. So this limit or this integration will be 8 by 3 x to the power of 5 for the limits 1 to 5 and c. So this is c times of 8 by 3, 5 to the power of 5 minus 1 to the power of 5. Put the value of c. What is c? C is 6 into 10 to the power of minus 4. So calculation. Good morning. So this is a calculation required here, and just put the values, calculate it, you will get the answer 1. So why did I take so much time here? I took so much time because you have to save your time in the examination, right? So you have to see like which one is going to be good or better. Should we take dx dy or should we take dy dx? That is something matters here, right? So if you are taking the order of integration as dx dy, you will have to do 2 of the calculation. Let's say this one and this one. Otherwise, if you are changing the order, only this one will be enough, right? And you'll get the answer as 1. Do the calculations and you'll get the answer, right? Calculation, which calculation? This one. So do you see the difference, right? So this is why you have to take a judgment like which order of integration is better. Let's move to the next question. In this question, you have to find the volume. Before good morning, Anmol Jha. Before moving to this question, I'll tell you something. For a function, for a surface, let's say for a surface, right? And this, let's say this is xy plane. Let's say this is xy plane and this is a surface. So this surface can be written as z equal to function of x and y, right? And in that case, maybe this is projecting certain region on the xy plane, right? It must be projecting certain region in the xy plane. Let's not say it is a rectangular or whatever shape it is. So the point is, let's say this is x, this one is y, and this is z. So you're getting the idea that z is a surface and the projection is on the xy plane, and then you have to, in order to find the volume bounded by that, whatever region is defined, whether like it can be an unbounded region, unbounded surface. So in that case, they'll give you a region, so that you have to find the volume enclosed in that particular region. Otherwise, it can be a surface which has no limits, maybe, right? So in that case, in this case, if you see, the equation of the plane is that surface. Plane is a surface, and this plane can be rewritten as z equal to 6 minus x minus y, right? So do you see this is a function of x comma y above the xy plane? And now if you have to find the volume, a triangle in the xy plane bounded, the volume above the triangle, right? So you have to find the volume of this. So what you will see in the xy plane. So this was a three-dimensional explanation. But now if I am talking about xy, only xy, let me go down. Let's talk about xy plane now. So in this case, the region is 2x is equal to 3y. So 2x is equal to 3y can be written as, let's say y is equal to 2 by 3x. There's no problem in this. Secondly, it is y is equal to 0. Y is equal to 0 and x is equal to 3. So this is y is equal to 0 and this is, let's say, x is equal to 3. Right? So the region enclosed here is this one. What is the value of this y? This line is y is equal to 2 by 3x and x is equal to 3 here. So the intersection will give you y is equal to 2, right? Put x equal to 3 here, so you'll get it. So this is the region enclosed here and you have to find the volume. So this volume is given as double integration for the region bounded, the function dx dy. Now I'm writing it dx dy generally, it can be dy dx, okay, whatever you find better. Again, if you see in this question also, I'm doing it again here. If you take the limits as like horizontal elements as dx dy, you will have to take this limit and this limit, right? So do you see both the limits are going to be the initial and final points, are both the points are going to be in terms of x or y, something like this. So instead of that, let's take a vertical element. So that this is, although any of it is good in this case, let's say this one. So I am doing it in terms of dy dx. So the y, limit y, we have already done so many questions. Kirti, please explain once again this question, please, sir. Okay, let me finish it and then I will like take a look again. So the lower limit lies on the line y is equal to 0 and the upper limit lies on the line y is equal to 2 by 3x, right? And the limits of x, so x starts from x equal to 0 and it ends at x equal to 3. So the limits are x equal to 0 to 3. What is the function? The function is 6 minus x minus y in terms of dy and then in terms of dx. Taking the lower limit y is equal to 0 is like helping you in the calculation. That is why you are doing it. The horizontal elements would happen in terms of a variable and a constant. So it would happen like a bit calculation would happen required. So it was my preference to take a vertical element. You can of course take horizontal elements, but you will see that there will be more calculations in it, right? So I'll go with my judgment. Okay, fine. Let's do this calculations here. So when you are integrating in terms of y, it is 6 minus x terms of y minus y square by 2. The limits are 0 to 2 by 3x, and then you have to integrate in terms of dx. I'm not writing the limits of x here. It is understood. It is 0 to 3. So putting the limits 2 by 3x. So let's split all the terms. 2 by 3x, so it will be 4x. Let me use another one. 4x, the first term, minus 2 by 3x square. Like you are putting y is equal to this. Fine. And then this one, the next one is y square. So 2 square divided by 2 will be 2 by 3 square, which is 9x square. Putting y is equal to 0 will make all the terms 0. This one 0, this one 0. So there is no point of putting it, right? So overall, if you see these two terms together will become 4x, and this will become, taking 9 as a, like taking 9 LCM, it will be minus 6 and minus 8 by 9x square dx. So you have to integrate it for the limits of y is equal to x is equal to 0 to 3. Do the calculations. So I'm writing it here. This is 2x square, the first one, and minus 8 by 9 x square. Is it x square? Yes, x square. So this becomes x cube by 3. Putting the limit 0 to 3. So if you put the lower limit 0, everything will become 0. So let's directly put the limit 3. So putting 3, it is going to be 2 into 3 square. So 2 into 3 square minus 8 by 9 into 3 cube by 3. So do you see this 3 cube and this will get cancelled? This is 3 square. So 9 to 18, and this final answer will be 10. So the answer is going to be 10 here. You do the calculations, right? I'll leave it up to you, although I have already done the calculations, but it is up to you. Do the calculations. So fine. What we were doing is, what I was talking about is, Z, imagine like all Kirti or everybody, just imagine like whatever table or wherever you are sitting here. So you consider your table base as your xy plane. Fine, you consider your table base as xy plane, and let's say you are bringing your hand upward. So if you see at different position of xy in the sense, if you are, of course your table must be, assuming your table is a rectangular. Hello Kanaya. So assuming your table is rectangle and on the corner you have x and y. So for every point of x and y, you'll have some point of z. So that is nothing but your, what is it? It is a surface. Fine, this is a surface. So similarly, what we are doing is, for x plus y plus z equal to c, we can rewrite it as z equal to 6 minus x minus y. So for each point of x and y, if you start putting the values x and y, what you will get? You will get the value of z. So if you start getting the values of z, what you will be making? You will be making a surface on this 3 dimension, right? And you can see it from the xy plane. And what if you are standing, or you can look from the top of that plane? If you can look from the top of that plane, just imagine this is your surface on the xy plane. You can look from the top, then you can see the projection of that particular bounded plane on the xy plane, right? The bounded region, like this, just imagine projection is like a shadow. Like if you are looking from upward, whatever region it is enclosing, that is the region bounded. So in this case, what they have saying, they are saying is, there is a plane. So they cannot give a bounded region, but they are giving a bounded region on xy plane, right? And that region bounded in the xy plane is a triangle which we have already discussed, right? So in order to find the volume above that triangle, which triangle? The triangle they are projecting on the xy plane. So volume above that triangle, up to what value? Up to the surface. So this is the surface, this is the, so this region. This is what you have to find the volume about, right? And rest is the calculations. So rest is calculation. You can do it. Fine. Done. Let's move to the next question then. This second question is for you. You will have to do it. Very similar. All you have to do is find the region. Of course, you can see the region is from y from 0 to x and x from 0 to 2. So you have to put the limits, z integration for that limits, double integration, right? Double integration. So I'm not solving it. You can solve it. In case you want the answer, I can tell you the answer. The answer is going to be, the answer is 864, right? The answer is going to be 864. And although one thing which I like to talk on this is, let's see the region first. Let's at least talk about the region. The region is y equal to 0, so this is y equal to 0. Y is equal to x, so this is y is equal to x. X is equal to 0, so this is x equal to 0, and x is equal to 12, so this is x equal to 12. Of course, you can see this is the region bounded. Now, if you take the integration order of fxy as dx dy, if you take it as dx dy, again what will happen? You will be taking a limit for x as x is equal to y, and then x is equal to 12, and then y limits whatever. What it will be? It will be simply y is equal to 0 to 12, right? But what if we are taking the vertical element? If you are taking vertical elements, again I am writing fxy. Of course, fxy is this one, that surface equation, and limits dx dy dx. If you are taking dy dx, what will happen? The lower limit will become 0. The upper limit will be y is equal to x, and the limits for x will be 0 to 12. I'm telling you, of course it is up to you, but my suggestion again is to use this one, because you can see the lower limit here is 0, this one is also 0, and then this is x, this is 12. So this will make your calculations easy. Yes, that's what I'm saying. Taking a vertical element will be easier here. If you take this dx dy horizontal element, you will have to put this, then you'll have 3 elements there. But if you start putting this one, you'll have lesser number of elements for the second integration, and that will help you to make the calculations easier. Like you'll have to do less calculations, right? And the answer is 864. I'm not doing it, but I'm leaving it to you. I don't have to do anything here extra, right? Let's move to the next question. Let's see. So in this case, obviously you can see there is a function sine x by x, and you know there are many methods which will fail to integrate this, like integration by parts or whatever, substitution, anything, manipulation, anything. This will not help you, right? So what you can do is you can change the order of integration, and maybe that will be of some help. So before that, what you'll need to find the region enclosed for this double integration, right? Whatever function this is. So dx dy. So the first limit is for x. So x is equal to y. This is x equal to y. The second one is x is equal to pi. So what is this x equal to pi? This is x is equal to pi. The lower limit of y is 0. So this is y equal to 0. And the upper limit is y is equal to pi. So this is y is equal to pi. You can of course see that this is the region enclosed, right? I don't have to tell you this again and again. So what we are trying to do is we are changing the order of integration. Maybe that will be of some help. So for the same function sine x by x dy dx. So the limits should be for y. Limits coming should be for y. So in that case, if we are taking the vertical element, this vertical element will have the initial point at y is equal to 0, the locus, and the end limit will be on y is equal to x is equal to y is equal to x. So I'm writing x, and the limits for x will be x is equal to 0 to pi. So write it, x is equal to 0 to pi. Right? Now you can do the integration. Why? Because this sin x by x is a function of x, and this entire thing can be treated as constant or fixed when you are integrating in terms of y. So what will be the integration? First integration will be sin x by x into y, because dy will give you y, the limits are 0 to x, and then you have to integrate in terms of x. So this will give you, answer is 1. I'll have to see. So putting limits y equal to 0 will become 0 and y equal to x becomes x. So sin x by x into x, integration from 0 to pi dx. So do you see this x and this x gets cancelled, and answer is not 1, it's 2. I think I'll have to come up to this, but I think like whatever I remember. So this is sin x by this x, both the x gets cancelled, right? Both the x are getting cancelled here. So you are left with integration of sin x dx from 0 to pi. Of course you can do this. You can do this. You want me to do this? Okay. This is minus cos x. The limits are 0 to pi. For pi it will be minus 1. So minus of minus 1 will be 1. And for cos x 0 it will be 1, and then, or we can change the limits. Cos 0 will be 1 and minus 1, so it will be 1 plus 1 equal to 2. I'm changing the limits, interchanging the limits to remove this minus. So answer is 2, not 1. Fine. Good. So do you see that order, a change of order actually help you to find the calculation? This is the application, another application of change of the order. Let's see the third one. Next one. This is triple integration. Although we'll see more of this, these questions in the volume integration, but let's have a taste of it. And before that, I'll have to tell you that just ignore this one. Fine. This is r square sine phi dr d phi d theta. So three-dimensional, maybe it is already written, spherical coordinates. We'll get to know what are these spherical coordinates and all. So we have to integrate this for the limits r, phi and d, theta, right? So you can start simply start with 1 by 1 calculations and put the limits and keep on integrating. That's it. That is all you have to do. But I'll still give you one more trick here. So the first one is r square. So the integration is r cube by 3. The limits are 0 to 1. I'm not putting the other limits, and it is sine phi is also there, and this is d phi d theta. Fine. So putting 1, this will become 1 by 3. Let's take 1 by 3 outside, and integration of sine phi is minus cos phi. The limits are from 0 to pi by 3, and you have to integrate all of this from 0 to 2 pi d theta. I'm skipping steps, right, because it is known, it is not something new. So putting the limits of cos phi as 0 to pi by 3, you'll get 1 by 2. Just interchange the limits. So cos 0 will be 1, cos pi by 3 is cos 60 is 1 by 2, so that is 1 by 2, 1 minus 1 by 2, so 1 by 6. 1 by 3 into 1 by 2. And then d theta. You don't have any terms of d theta. So theta for the limits of 0 to 2 pi. So this is 1 by 6 into 2 pi, which is pi by 3. That's it. This is the answer. Fine. Pi by 3 is the answer. All you are doing is taking one integration, keeping the rest as fixed, putting the limits, then integrating the result for the next variable. Like we started with dr, integrated in terms of r, then integrated in terms of phi, then integrated in terms of theta. Keep putting the limits one by one. That's it. You don't have to do anything new here. But I can also tell you one more thing here. That is when the limits are independent. What do you mean by limits are independent? If you see the limits of r is equal to 0 to 1. Is it depending on any other variable like phi or theta? No. Similarly, phi is the limits of phi is 0 to pi by 3. It is not depending on any other limits. Fine. The limits of theta is 0 to 2 pi. Again, it is also not depending on anything else. So what you can do is you can find this integration as d theta from 0 to 2 pi into sine phi d phi from 0 to pi by 3 into r square 0 to 1 dr. Right, what I am trying to do is integrate all these three and then put the values. You'll get 2 pi into 1 by 2 into 1 by 3, which is again pi by 3. The good thing is you can only do it when the limits are independent, right? If the limits are x is in terms of y, you cannot do this. If all but when the limits are like this, suppose for double integration you have x is equal to a to b and y is equal to from c to d. Let's say all these are constant, dy dx. In this case, you can change the order of integration without, you don't have to change the limits. Why? Because if you see, x is also having constant limits, y is also having constant limits. So this can happen only when it is a rectangle. Right? This is only possible when it is a rectangle. Like this is, let's say x is equal to c. This is x equal to like mind the limits. Maybe I am writing something else, but just be careful about the limits. So the limits for x is a and b. So this is x is equal to a, this is x equal to b, this is y is equal to c, and this is y is equal to d. So do you see that this is a rectangular region and you can change the order of integration, but you won't have to change the limits. Limits in the sense x limit will remain limits of x and y will remain y. Because taking a horizontal or vertical anything, you'll see the limits are constant. Right? So this is all about multiple integration. Let's move to the next topic also. We have to cover one more part. And fine. Fine. Let's move to the next topic, which is gradient, divergence, and curl. Before moving into this, we can of course see some of the formulas. You know the formula of gradient. Gradient is found for a scalar function and it is given as the derivative of in terms of x, y, and z as I, j, k components. This is the formula of directional derivative. This is gradient of that function dot product with a unit vector in the direction in which you want to find the directional derivative, right? And then divergence and curl. Divergence and curl both are found for the vector quantity, but divergence for a vector quantity is a scalar and curl of a vector quantity is a vector itself. Whereas for the gradient is found for a scalar function, but it is a vector. Fine, it is a vector. You just rewind whatever I have said, as I have completely defined everything. Right. So this function is nibble, and this is just a dot product of the vector I, j, k components with the derivatives di, dx, d, dy, d, dz. Other than that, important results are there, like divergence of gradient can be found like this. Gradient is found for a scalar function and it will be a vector function. Divergence can be found for a vector function and the result is a scalar function. So at the end, this will be a scalar function, and this is possible only if the function f is double differentiable in terms of x, y, and z. Other than that, curl of a gradient is always 0 and divergence of a curl is always 0. So what I remember is CG is 0 and DC is also 0. Right? This and all can be used somewhere. We'll see some more terms, but afterwards. So let's start with the first one. Simple one. So there are quick calculations, and let's hope we don't take much time here. The first one is, this is your f. Fine, this is your f, and the gradient of this function will be df by dx, I component, df by dy, j component and df by dz k component, and of course then you'll have to put the values, right? So let's do it. If you see in this f, there is only one term in terms of x. There's only one term of x, which is x square. So for y square and z square, derivative with respect to x is going to be 0. So this is going to be 2xi component. Then in terms of y, there is only one terms in terms of y, which is 3y square. So this is 3y square differentiated will be 6yj, and in terms of z, there is only one term, which is 2z square. So this is going to be 4zk. Now you can put the points as point which is 1, 2 and minus 1. So this is going to be what? 2i plus 12j and minus 4k. So you check the limit, check the options. It is B option, 2, 12, minus 4. Done. So nothing much here. You have to put it directly. Right. Next question. It is good one. Mechanical 2018. This is a good question. Let's see. They say for this R as xi plus yj plus zk. What is this R? Absolute value of R, which is under root of x square plus y square plus z square, and this R is nothing but the positional vector. Of course we know this. So you have to find the gradient of phi. So what is this phi? This phi is ln of R. Can we write it as ln of under root of, or instead of under root, is it okay if I write it like this? Is it okay if I write it like this? X square plus y square plus z square to the power of 1 by 2. It is fine. And I'm taking this 1 by 2 outside. So I'm writing it ln 2 x square plus y square plus z square. Just for my sake, maybe I'll need less of calculations and differentiation. Now what we can do is, we can find the gradient. So the first, like we have already seen in the previous question, first we have to differentiate this term in terms of x. So 1 by 2 ln of, so this will be 1 by 2, 1 by, I'll need more space I think. Let me write here. So I'm writing it here. So this is going to be 1 by 2 ln of this will give you x square plus y square plus z square. So what is this first differentiation? It is in terms of x. So considering y square and z square as constant, you will have to, using chain rule here, you will have to differentiate x square also. So this will be 2x directly, or you can remove this. This is fine, only 2x. This is I cap. Similarly, in a similar fashion, you can do it half of, writing it directly 2y, because it is all same. This one is in terms of the differentiation in terms of y, and third one is in terms of z. So this is 2z x square plus y square plus z square k cap. Also you can remove all these 2 and 1 by 2. You will be left with, and you have a common base denominator. So I am taking 1 by x square plus y square plus z square outside, and inside 2 and 2 gets cancelled, and it will be xi plus yj and zk. Now if you remember correctly, I am writing it here. If you remember correctly, this r, which is under root of x square plus y square plus z square, so square of this absolute value will be x square plus y square plus z square, which can also be given as r dot r in the sense of vector, because dot product of the same vector gives the square of that absolute value. You know this, right? So instead of that, what we can do is, and this numerator is nothing but the r vector. So the final result of this gradient will be r by r dot r, right? I'm just putting the values correctly in the format so that the final result which comes out is option C. Correct. Option C. So what we are trying to do is substitute some of the expressions which we already took out as a like expanded form. Fine. Done. No, nothing. No problem will be there. It will be directly done like this. Let's move to the next question, which is directional derivative. So for directional derivative, you need to have few things. First, you need to have a gradient. Then you need to have a gradient at that some point. Then you need a direction in which you want to find the directional derivative, and you have to make sure, if you like, as a part of the calculation of formula also, you have to make that vector as a unit vector, like the vector in which direction you need to find the directional derivative, right? So first of all, you need a gradient. So let's say you have this gradient grade f as, so this is f, right? So this f has one term of x, so we will differentiate, the other term will give you 0. So this is 2xi, and when you differentiate in terms of y, this will be treated as, x square will be treated as a constant, and you can differentiate y, and you can write 2yj, right? This is the gradient and first place. Secondly, what direction they are talking about? Along a line directed from 0, 0 to 0, 1. So this is 0, 0 and this is 1, 1, right? So you can find this vector, a vector. This will be x2 minus x1. So 1 minus 0 I cap, and y2 minus y1 j cap. So this is nothing but I plus j cap. And if you need to find the unit vector, this is going to be I plus j divided by under root of 1 square plus 1 square. So you can write 1 by root 2 I plus j. Correct? Right? You know how to find the unit vector. Also, you have to find this directional derivative at the point P, which is 1 comma 1. So let me write this. You need to find this at point 1 comma 1. So let's put this value here. So this gradient at this point will be 2i plus 2j, right? So this directional derivative at this point P will be the gradient at P into a unit vector. I'm not writing a vector, I'm writing unit vector. This becomes 2i plus 2j in dot product with I plus j divided by root 2. Root 2 is the absolute value of this. So you need to put this so that you can change your vector into unit vector, the vector in which direction you need to find the directional derivative. So this will become I and j will give you 1 I dot. So this is 2i and 2 plus 2 divided by root 2. So this is nothing but 2 root 2, and this is option C. Fine, 2 root 2. So this is how you have to find the directional derivative. Clear? I hope there is no problem. All you have to see is, you like the gradient whichever you find, it will have its own direction, but you need to see a component, a projection of the gradient in the direction they are asking you. So the direction they are asking you is a line joining from 0, 0 to 1, 1. So if you have to find the directional derivative in this vector direction, you'll have to dot product it with the gradient and make sure divided by the absolute value of that vector also. Yes, of course, it's easy. So I'm leaving this one also for you. Directional derivative, all you have to do it is in this similar fashion. I'm dropping this because of course you can do this. You can do it for the practice. If you want the answer, I think answer is 1. A option. Right? You have to do everything same. You have this function, you'll have to find the gradient. You also, and you have to put it for point P. Let's say this is point P, and you have to dot product with P. Let's not confuse with capital P and small p, divided by the absolute value of P. That's it. Let's say this is a vector, right? Let's not confuse with capital P and small p. If you have a confusion, I'm changing the points. Let's say this is a point A not A, maybe Q. Fine. So I'm leaving it, and we can move to the next question, which is about finding the surface norm. So this gradient can be like, it is also taken to be a surface normal, and if they are asking you about unit vector, all you have to do is find the unit vector of the vector you are finding. So all you have to do is find the gradient. So the function is already given. This is the function, right? So the gradient of this function will be, of course this can also be done directly. The first term is x square, so it will be 2xi cap plus similarly 2yj cap plus 2zk cap. Now you can put the values as, the points are 1 by root 2 comma 1 by root 2 comma 0, because you have to find it at this point. So this becomes 1 by root 2 I cap plus 1 by root 2 j cap. K cap will be 0 because the z component is 0. Now, is this a unit vector? Is this a unit vector? I think yes. Why? Because you can find the absolute value. Let's say this is a vector. Let's say, or y a. Let's take n, because they want to find the normal vector, right? So let's say this is n. So the absolute value of n is under root of 1 by root 2 square plus 1 by root 2 square. So 1 by 2, 1 by 2, 1. So this normal vector is itself a unit normal. If it is not a unit normal, you will have to make it unit normal, because they are not asking you normal vector. They are asking you unit outward normal vector. What is outward? Of course, you know that. So suppose this is a sphere. So if they are asking you to find the normal vector, you will consider outside. You won't consider inside, right? You take outside. So this is outward. So it is like, by default it is a unit vector, so you don't have to do any calculation. So this is how you have to find the surface norm. Let's move to the next part. These are small and like small thing, but of course you have to do. There are good questions also in this one. I'll leave the smaller and easier question for you, and then we can do the good questions. So you have to find the divergence here. Divergence is found for a vector quantity, but it is a scalar quantity. So let's say we have v is equal to v1 I cap plus v2 j cap plus v3 k cap. Then divergence of v can be given as dv1 by dx plus dv2 by dy plus 3 by dz. So this is your v1, this is your v2, this is your v3. Clear? So the first one you have to differentiate with respect to x, the second with respect to y, and third with respect to z. So x square differentiated will give you 2x and y cube, so 6y square, and third term differentiated will be 4z cube, and the point is also given 1 comma 2 comma 3. Put it. You can put this, and I will help you with this. The value is going to be 134. Put x is equal to 1, y is equal to 2, and 3, z equal to 3. You will get 134. This is the divergence at this point. So do you see this is a scalar quantity? Yes. So that's what we were talking about. It is going to be a scalar quantity. Done. There's nothing to explain much here. There are good questions, so you'll have to wait for it, because we need to cover up some basics and easy questions. This is another easy question. I'm splitting the u here just for you. This can be written as ex cos y I cap and ex sin y j cap. Differentiated with respect to dx, and this one in terms of dy. This in terms of dx will give you I'm writing below. The first differentiation will give you e to the power of x cos y, and second term will be in terms of sin y. So sin y differentiation is cos y, so e to the power of x cos y. So it is 2 e to the power of x cos y. Done. I mean, it is very simple. So I was not going to solve it, but I did it. It was for you. The next one is a good question. Let's just see this one. This one is good. There's an extra function here, u. What is u? Is this u a scalar or a vector? U is a scalar function. That means u into a. What is a? A is a vector quantity. That means you are multiplying a scalar with a vector function. I'm not saying it is a constant function. I'm saying it is a scalar function. So scalar with a vector will give you another vector only, right? Of course, scalar. So let's say if this is a1, this is a2, and this is a3, right? I'm just making. I'll spend more time here so that you can understand how to spend less time. That is my motive here. So this is a1, a2, and a3, and what you will get after this is, I'm writing it as u_a1 as I cap, u_a2 as j cap, and u_a3 as k cap. Of course. Hello. Hello. I cannot pronounce your name. Sorry, but hello. Hello with that fire. Okay. So u is a scalar. I'm multiplying with all the components of a, I, j, and k components. A1, A2, and A3. I'm assuming it like that. Now, when you have to find the divergence, what you need to do is you need to differentiate this one. Differentiate this one with terms of x, this one in terms of d by dy, and this one in terms of d by dz. Correct? Now, is this u independent of x, y, or z? The answer is no. U is having all three components x, y, and z. But when you are differentiating in terms of x, you will consider y and z to be constant. When you are differentiating in terms of y, you will consider x and z to be constant. When you are differentiating in terms of z, you will consider x and y to be constant, right? So all you will have is the result. The result is going to be, divergence result is going to be, of course you will use the product rule, right? You have u into a1 and you have to differentiate this with respect to x. So I'm writing it as u dash a1 plus u a1 dash, right? Plus u dash a2 plus u a2 dash plus u dash a3 plus u a3 dash. What I didn't mention, and it should be understood, that these differentiations are with respect to x, with respect to x, with respect to y, with respect to y, with respect to z, and with respect to z. Yes, that is what we have to do here. Okay, and what point we have to find it? We have to find it at 1, 1, 1. So I'm writing it here 1, 1, 1. We cannot put it now. Why? Because we have to differentiate it at some places. So let's see this. I'm writing this function u again. This was x square plus y square plus z square. Okay, let's keep this in the frame. So u differentiated in terms of x will be 2x. 2x into a1. What is a1? It is 2x. Plus u. I'm writing u as it is. U into a1 dash. What is a1? 2x. Differentiated in terms of u x will be 2. Correct? U dash in terms of y will be 2y into a2. What is a2? 3y. Plus u. So what is u? U, keep it like that. Y a2 dash in terms of y. What is a2? A2 is 3y. Differentiated in terms of y will give you 3. Plus u dash z. So what is u dash z? It is going to be 2z into a3. What is a3? A3 is 4z plus u. Let's write u at like that only. And a3 dash. A3 dash is in terms of z. What is a3? A3 is 4z. So it will be 4. Right? I'm just spending more time so that you will have to spend less time afterwards, and you'll be very clear. Now I want one more thing. What is u at the place of 111? So 111, it will be 3. Now all you have to do is, for this case, is you have to put the value of 1 comma 1 comma 1. That's it. Do this. Now it is not so difficult. All you have to do is put the values, right? So 2x into 2x, x is equal to 1. So this is 4 plus, what is value of u? U is 3, right? So start putting u equal to 3 everywhere. So it is 2 into 3. So let's say 2 into 3 is 6 directly. 2 into y into 3 into y. So y is equal to 1. So 2 into 3 is 6. U into 3. U is 3. So 3 into 3 is 9. 2 into z into 4 into z. So z is 1. So let's forget about the z. 2 into 4 is simply 8. U is 3. So 3 into 4 is 12. Right. Instead of u, you start putting 3. And instead of x, y, z, you put 1. So the result is 10, 30, 45. 45 is the final answer. Fine. So the final answer is going to be 45. So that's it. Instead of expanding u everywhere, you don't have to do this. You don't need the expansion of u everywhere. And that is why I am not doing it. Clear? So 45 is the answer. Move to the next question. We have got few more questions here. Fine. Let's talk about curl now. We know what is curl. Let's see what are the expressions. The first one is 2x square y. The second one is 5z square. The third one is minus 4yz. Do it. I think you don't need me here. You just have to do it simply. Let's do it. I term. So it is d of minus 4yz. Shall we start putting directly? Differentiation of minus 4yz in terms of y will be minus 4z, and differentiation of 5z square in terms of dz will be minus of 10z minus j of j. So dx of this term 4y square, this will be 0, and dz of this term 2x square y, this will also be 0. I can write minus 0, anything is okay. Of k, so dx of 5z square 0, and dy of 2x square y, so this is minus 2x square. So the result is going to be minus 14zi and minus 2x square k. So what is the result? The result is D. Right? Small calculations required, and I mean, you don't have to calculate, you have to just differentiate. Calculations is not required because no point is given here. So this is going to be the answer. That's it, done. Next question. Fine, next question. It says this is a vector and you have to see that it is irrotational. For the case of irrotational field, the curl has to be 0. Let's say f, yes, f is equal to 0. So somehow you have to find the curl to be 0 so that you can find the values of k1, k2 and k3. Right. So let me write it here. It is I, j, k. The terms are, the first term is 3y minus k1z, second one is k2x minus 2z, and third one is, since do you see there is a minus outside, so use this minus here. So this is minus k3y minus z. That's it. Now you equate this to 0. Writing it here, this should be 0. So let's write the first term I. Dy of this, differentiation of this term will be minus k3, and I think there's no another term, right? What is it? Right, no other term, minus dz of this term. So k3, k2x will be differentiated as 0, and this will be minus of 2, right? Minus k3 and minus of 2, if I am right. K2 minus 2z. Fine. Minus j times of, for j, dx of this term. So this is like no terms in terms of x, so I'm writing it 0, and dz of this term. So there's one term in terms of z. This is minus of minus k1 plus k times of k. So dy dx of this term. So there is one term of x which is k2 minus of dy. So minus of 3 should be 0. Now you have to see that I, j, k components are all independent components. You cannot calculate them together, right? So if the curl is 0, that means all the terms of, like all the components I, j, k has to be 0, and that is possible when you make this minus k3 plus 2 equal to 0. So that means k3 is equal to 2, k1 equal to 0, and k2 equal to, like k2 minus k3 equal to 0, so k2 equal to 3. That means k1, like in terms of k1, k2 and k3, we have 0, 3 and 2. 0, 3 and 2. 0, 3 and 2. Option B. So you cannot mix your I, j and k components. They have to be independent here, right? So putting this curl to be 0, you'll get the result for a rotational function. Next question is a quickie. I won't solve it. Why? It is divergence of the curl. I don't know what is the field, but it is divergence of the curl. And in the previous results which you have seen, you'll see do we have it somewhere? I cannot go that up. Yes, we have it here. 1 second. So we have it here. We have already said, yes, see this. The results. Divergence of the curl is 0, curl of the divergence is 0. So both the terms are 0, and what we are asked here is they're asking about divergence of the curl. So without calculation, I'm writing it 0. Fine. So the result is 0 directly, whether it is divergence of curl or curl of the gradient. Anything is 0. Apart from this, the next question, we have two small questions. It won't take more than 2 or 3 minutes. Two things, I'll write it here. First thing is, if divergence is 0, you can say two things. If it is a fluid, you can say it is incompressible. And if it is an electrical field or anything like that, you can say it is solenoidal. Secondly, if the curl of a field is 0, you can say two things. One thing is it is irrotational, and second you can say it is conservative. How it is conservative? If you can come up with some of the theorems, maybe Stokes theorem will help you to find this. Two things. So divergence of this field E is 0, so it is solenoidal. True. Curl of this field is 0, so it is conservative. True. Fourth one. And curl of this field is 0, so it is irrotational. True. This one. Now the third last option is divergence is 0, but it is saying irrotational. So this is the option which is wrong. Fine. This is the wrong option. Option D is wrong. You have to take care of this fourth thing. That's it. Let's see this question, the last one. Divergence and curl. Right. So what about divergence? If you talk about divergence, we have already discussed in the theory part also. It is about source and sink. So if take it as a fluid or field, whatever, if it is coming out of a source or a point, you'll say that it is a positive divergence. It is a positive divergence. Similarly, if it is going into it, it is a negative divergence. And if it is like this, like whatever is going in is coming out, whatever is going in is coming out, then it is a zero divergence. So do you see that first one is something with positive divergence, or you can say non-zero divergence, non-zero. Second thing is a rotational moment. Do you see this is a rotational moment? So if it is a rotational moment, the curl should be non-zero. And similarly, you can see in this case also, there is a rotational moment, right? So for this case also, the curl should be non-zero. So overall, divergence non-zero, and curl non-zero is the combination you have to select. So it is option C, right? Option C is the answer here. I think this will be enough. Fine. So these are some of the questions. Apart from this, so this is where we wind up. And in the next class, we'll be moving into the vector calculus, like we'll be discussing line integration and surface integral and volume integral. We'll try to finish it in the same day. Maybe it will take, of course, it will take more than 1 hour. But a little understanding of gradient, divergence and curl is required in the application in the next two classes. Two classes in the sense, the next class which will be about line, volume and surface integral, and after that we'll be moving into the theorems, Green's theorem, Stokes theorem and Gauss theorems, right? So with that we will be finishing up this calculus. Fine. So this was all about it. Both the topics are important. You'll come up with small questions here, and that will be like helpful for you. So keep learning, keep sharing the app, and keep like sharing the app in the sense you have to share the link with your friends. Put a thumbs up on the video, and bye bye. Happy Sunday. Bye Kirti. Bye Ashutosh. Bye everybody. Okay then. Thanks a lot.